Okay, so we are on. Today we're going to take a look at section 2.6. So if you have not already in your notes, would you please go ahead and get ready for that? Leave your homework out because Mr. Yoakum, as he makes it around, will check with you in regards to what your homework looks like last night. But today we're going to look at two ideas. It's going to seem kind of strange for a second because these two ideas, how do they relate to us solving equations? That's all we've been doing up to this point is solving equations. Like now we're talking about ratios and proportions. In this case, we're going to find out that proportions and equations really work seamlessly together. Okay. Do you know, first of all, though, what a ratio is? I think the answer is yes. Whether or not you really have a definition in your mind of a ratio is really just a comparison of two numbers. Okay. So you can think about that in a cooking situation. You want to compare how much of one item to another. You want to think about it in a competitive situation, like comparing my points to your points or something along those lines. And when we take two of those ratios and we put them together, if they're equal to each other, that's a proportion. And I think you guys have some knowledge of solving proportions as well, and we'll kind of touch on that today. If you do not have a calculator in your hands, you're going to need one. If you don't have a calculator, period, and you need to borrow one from me, go to the back, get one, but just remember you'll have to wipe it down before you turn it in. Okay? So here's kind of a list of what we're going to look at today. We're going to start right off the bat with trying to figure out whether ratios are equivalent. What's it mean to be equivalent to each other? Caroline? They're equal to each other, okay? And honestly, I don't care how you figure this out. I'll just ask what it is you used to answer that question. So we're going to start by comparing ratios, and then we'll get into the idea of proportions. So starting here, like I said, I don't really care what your thought process is on why you think it's yes or no. I just would like to know why you think it's a yes or a no. So take a second, look at those two ratios. And the question is, are they equivalent or are they equal to each other? Whatever you're going to tell me, I just want to know why. Like, what's your thought? And if somebody has a different thought than you, please share your thought. If it's the same thought as somebody else, obviously we don't need to hear the same thought twice. Trent, what are you thinking? Okay, and by what reason?
Well, each time, if you want to do 49, it's like 7 times 7.
Okay.
8 times 7,
Perfect. So you multiply by the same factor each time. All right. Anybody do something different than that to prove? Ian, what'd you do? How did you simplify it? Well, like, did you use the ABC button?
Yeah.
Okay. So you reduce that fraction to see if they work. Okay. Anybody do anything else? I mean, the answer is yes, by the way. Caroline, what'd you do? Sure. Turn them into decimals. Yeah. Did they come up with the same decimal? And in this case, the answer is yes. Anything else that you guys did different than something that you heard? All right. I'm going to show you one more, but I'm going to ask you now, don't do the same thing you did before. Use some different method, whether something that you heard or something else you're thinking might be a way you could show this. So try it with these two. Don't do the same thing you just did. Try something new. We heard multiplying by a common factor. We heard reducing them. We heard turning them into decimals. Are these two fractions equivalent? Dominic, what do you think?
I said they were not equal.
Okay. For what reason?
If you divide the two denominators at top.
Numerator is top.
If you divide the larger numerator by the smaller numerator, you should get the denominator of the bottom. So if you divide 40 divided by 5, you should get 6 if they were equivalent.
Well, you did 40 divided by 5, you get 8.
Yeah.
If I did 49 divided by 6, I should also get that same value of 8.
Yeah.
Okay. And we did not. Okay. Chris?
No, I turned them into decimals.
Sure. Two different decimals, right? Okay. Anything else you guys can think of? Okay, so we're going to talk about one more method. I think you actually know this, Not by this goofy name. Okay, I'm sure I would put money on it that you've never heard the phrase the means extremes property. Anybody? Okay, but I bet you do know this idea. Here's why. How many of you could solve this? How many of you know the answer to this? How many of you guys could solve that? By doing what? Ian, what would you do? Cross multiply and divide, right? So take a second, use your calculator. Tell me what you get. Annalise, what do you get? What do you get? 2? Agree? Yes? Okay. So that means this value is a 2. Okay. Here's what the means extremes property says. And it falls right in line with your idea of cross products and this idea of cross multiplying and dividing. That these two values right here must be equal to these two values right here. Meaning, what is 2 times 36? And what is 6 times 12? 72, right? And that's why they're equal to each other. All right? So if I came back here for a second, we said yes, that these two were equivalent fractions, correct? What is 7 times 56? 392. Take a wild guess what 8 times 49 is. Do you really need to write 392? And so that's where this idea of cross multiplying and dividing comes from. It comes from the fact that your cross products or your diagonals or these means and extremes are actually two equivalent statements, two equal statements, right? It's what allows us to be able to find quickly whether or not something forms a proportion. So, looking at these three, my question to you would be, thinking along those ideas, can you tell me, are any of those three proportions? Meaning, are they equal to each other? Think about those cross products, we might call them. Bet that means this is going to crash again. It's my guess. We'll find out. Annalise, what do you think?
I think the first two are not equal.
Not proportional?
Yes.
Okay. But the last one is?
Yes.
Okay. How many of you agree with that statement? How terrible to make the first two not work, all the way down to the third one to make it work. Who would do such a thing? Thank you. All right. Now, I would venture to guess you all can answer that just as easy as you answered the last proportion that I showed you. Take a second. Tell me what your answer is to that. Landon quickly has an answer of 4.5, right? If we think that diagonal there has to be equivalent to that diagonal there, so therefore we end up with 36 divided by 8, and we get 4.5. Now, what if we make it a little bit harder? Can you use the same thought process to figure out what the missing piece is here? Take a second. I'll give you a minute, maybe. If you haven't figured it out at that point, we're probably going to need some other idea. So take a second, see if you can come up with it. I'll tell you, if you're wondering if your answer is right or wrong, it is a single digit number. Okay, he's out. Remember, think about those diagonal values and what they're worth. In this case, we know one of them. We can use that to our advantage. You got it. You got me nervous though with all those zeros after. I was like, what in the world? I wonder why it says it.
I have no clue.
I think you just have a setting changed. I'll find it for you. I mean, I know what it is. I just need to find it on this calculator. I'll play with it. Well, I'll fix it for you. All right. At this point, I saw 1. Caroline, what did you come up with for an answer? 5. How did you do it?
I took 12 times 3 to get 36.
Okay, so we know that that diagonal's worth 36. Okay.
And then I took that and divided it by 4.
Okay.
And then subtracted 4.
Okay. Now, the yellow diagonal and the green diagonal have to equal each other. Are we in line with that statement? So we know that if yellow's worth 36, green's also got to be worth 36. But you can see that green already has one of the factors given to you. Can you tell me the other factor that would need to be right there in order to also equal 36 like the yellow? 9. Meaning this spot has to be worth 9. Not X, but that spot itself, that numerator's got to be worth 9. Well, you already had a 4 in there. So Caroline says if I just take the 4 away, that means that this spot had to be filled with a 5. Yeah? You seeing it? All right. I'm going to pull one here. It's actually from your homework. So when it's in your notes, you can just reference it on your homework that it was one of the problems we did in class, okay? Try it. This is it. This is number 8. So when you get to your homework, you'll just be able to reference back and you can write your answer down. So 3 over 12 is equal to 2 over y plus 6. I'll tell you this one also is a single digit number. You have it already. That's what that spot is worth. It's not what y is worth. But you're really close. I think many of you guys are figuring out what this value, what this location is worth. Remember though, you need just the value of y, not the value of the whole location. You have it, Delaney? What is it? 2. Very good. Okay. How did you figure that out, Delaney? Okay, so that's equal to 24. Okay. Okay. So that was 24, and 24 divided by 3 was 8, and then you took off 6, which meant that this spot right here had to be worth 2. Very good. You ready to make it a little bit harder? Okay. What if I don't tell you what either diagonal is worth? Now, we can't totally use our thought process from a second ago because we're missing something, right? We don't know what either of the diagonals are worth. But there's something that we know about both diagonals. Graceland? We do know the denominators, yeah. I'm thinking this way. There's something I know about the yellow line and the green line in relation to each other. Trent?
Well, they both have like, and then after the first,
True. True. Listen, I don't know what they equal, but I know that they equal each other. Cross products have to be equal to each other. Are you with me on that statement? Listen, I have no clue what 5 times 3n plus 3 is, because I don't know what the n is. And I don't know what 2n minus 4 times 10 is. But I know that those two things are equal to each other. And we know how to solve an equation, right? So if I can write them as two statements that are equal to each other, I will have created an equation. And we all know how to solve an equation. Here's the only thing I got to do. I got to make sure that I write it correctly. In the yellow scenario, it is 5 times 3n plus 4, not 5 times 3n. How do I write that I'm doing 5 times both the 3n and the 3? I got to use something. Sophia, you know what it is? Yeah, good. I have to show that I'm multiplying both of those things by 5. Now, that statement right there is represented by the yellow line. What represents the green line? What am I going to write on that side? Chris? Okay. Have we solved enough equations to know what to do here? I hope the answer is yes. What does your first move have to be, Graceland? Yeah, what's that called when you multiply something outside the parentheses? The distributed property. Good. So if you have not done so, you need to distribute. You make your distributions. You should have those two statements. Landon, what's up? You have an answer? Is it a double-digit number? Are both of the digits the same value? Then I think you're in good shape. You don't have a whole lot of choices there, right? Caroline, does yours match that statement? Okay. Move your variables to one side. Does it matter which side you move them to? No, not really. Just move them to one side. Move your constants to the other side. Don't move them to the same side. That's really your only requirement. I think I'll move the 15 in. That will leave me with 15. What did I just do that for? Oh no. Bad news. Get out of there. I'm going to minus the 15, but I'm going to cancel. That's the one that cancels. 15 is equal to 5n minus 40. And I'm going to add 40. And I'm going to get 55 is equal to 5n. And when I divide by 5, there's my double-digit number with a repeated value. I get 11. Right? Okay, so if I don't know what one of the diagonals is worth, that's okay. I can rely on the fact that I know they have to be equal to each other, which is what you really used before. Like in the last one, you knew that it was equal to 36. I think it was 36. And you worked backwards off of the 36. Well, here I just don't know that, so I just kind of am one step further behind. All right. I'm going to give you one more from your homework to practice. So we'll put this one in our notes and then we can kind of just steal it for our homework later. And then we have one thing left and we're done. This will be, this is number 10 from your homework. Okay. So 4v plus 7 over 15 is equal to 6v plus 2 over 10. Disclaimer, this one will come out to be a decimal and or fraction, so don't feel like your answer's wrong if you get a decimal or a fraction. Remember, your cross products have to be equal to each other. Remember, if you write your two cross products, you're going to have to distribute your distribution you see on the board. So you can check that to see if it matches what you have. And then it's just simply moving those variables to one side and moving your constants to the other. There's no variable on this one, but there is on that. So it's these two that have to go together. The 30 should be over there. Very good. You have to do 10 times, that's 70. And 15 times 2, that's 30. You added them. You did 10 times 4, and you got 40. But you did not do 10 times 7. You did 10 plus 7. That should say 70. And the same thing here. 15 and 2, that should be a 30. Your work is correct. So I'm going to move the smaller variable. Leaves me with 70 is equal to 50v plus 30. I know a lot of you guys like to move your variable to the left, but if you do that in this situation, it gives you negative values. I always usually move my smaller variable. So last thing, move the constants so that they join up, and you'd be left with 40 is equal to 50v. I had a student earlier who got to right here and just decided that he knew which one was going to be the division, and he did 50 divided by 40. Don't do all your work and get to here and then decide not to show your last step, because as soon as he showed his last step, he understood that he had to divide both sides by 50, not by 40. In this situation, you can cut the zeros, essentially dividing them each by 10. You get left with an answer of 4/5 or 0.8 as a decimal. All right. So don't do all that work and then get to the very end and then decide to shortcut it and then get it wrong. Like that doesn't make sense. Okay. Last thing and we're done. Now that we've kind of looked at all these ideas of a proportion, is how do I take it and how do I apply it some way? All right. And I see the look on some of your face. You see all the words, right? And you're like, oh, here we go. Well, just stop for a second, right? Forget the goofy little pictures at the bottom, but they're there honestly for a reason. If you've ever been on a bike ride with a little kid, they have to pedal way more than you have to pedal, right? And you just like, their poor little legs never stop pedaling the entire time just to try to keep up, right? Well, it's all about the ratio that's built into their bike. It's easier for them to pedal, so they have to do it more times to get the same revolutions that you're getting off your bigger tires, your bigger gears, and all those pieces. So here, the ratio says that it's 8-5. And that means pedal 8 times and get your wheels to turn 5 times. That is a ratio. Can you see that? Can you visualize what that looks like? Okay. If I'm going to work with it, I don't typically write it with a colon like I see here. How am I going to write it? If I'm going to work with a ratio, how am I going to write it? Sophia? I'm going to write it as a fraction. Remember, 8/5. Okay. So if I write 8/5, so here's the question. Suppose the bicycle wheel turns 2,435 times. How many times would the pedals turn? What am I building? What am I making? What have we been working on all period? Making a proportion. So the question is, if I'm going to make a proportion, where does the 2,435 belong? In the numerator or in the denominator? What do you think, Delaney? In the denominator, right? It says that 8 pedal turns is equal to 5 wheel turns. Well, this is 2,435 wheel turns, so I'm looking for that. Knowing that the relationship is 8-5, should your answer be bigger than 2,435 or should it be less than 2,435? Should be bigger. Look at the fraction. Numerator's bigger than denominator. Your answer better be the same way. Is it? What do you got, Landon? 3,800 and
46.
is it 46? 96?
Or 96.
96. Okay. Problem's easy if you set up the proportion first. Okay? All right.